Hello, so let's have a look at this circuit and try to understand what this circuit is and how it works. So as we can see, there is a AC input applied to this circuit and there is an AC alternating current output coming from this circuit, and the circuit contains your transistor, that is BJT, which is connected as shown. So we see that this is an NPN transistor. Why? Because the arrow which indicates the direction of the conventional current that is coming out of the emitter. So the conventional current in this transistor flows from collector to emitter, and that's why we see it is an NPN transistor, and it has a collector, base and the emitter. These are the three terminals, and this is your N, this is your P, and this is your N. So collector is your N type of material, emitter is your N type of material, and base is your P type of material. Now we see that the AC input is applied to this circuit. This capacitor C1 will filter out a DC component present in this AC input signal, and then a pure AC comes at this node right over here. Now we see that there is a, in order to for this circuit to work as an amplifier, for example, along with the AC signal you need to bias the circuit with the DC voltage sources. So to set the operating point of this circuit, which we call it as a DC operating point, is also called as Q point or quiescent point or DC bias point. So how to do that? So we use the voltage sources here, as we can see that. So this first voltage source called as VEE, we see the positive is connected to the base and the negative of it is connected to the emitter through this resistor RE. So we see that the base is a P type of semiconductor to which the positive of the battery is connected, and emitter is N type of semiconductor to which the negative of this VEE source is connected. So through this resistor the negative comes here. So because of this junction, which is called as base emitter junction, is forward bias, and we call the voltage across it is a VBE, where base is positive with respect to emitter, and we see that is how it is biased. So this VBE across the junction, which is forward bias, is applied. So that's the input side of your circuit. Now again let me put the notation N, P, N. Let us look at the output side of this circuit. So this is an output side indicated by arrow. So we have another voltage source. So negative of this voltage source VCC is connected to the base, which is a P type of material, and the positive of this is connected to the N type of semiconductor, which is a collector, through the resistor RC. So we see that this junction, the base collector junction, is reverse bias because N is connected with the positive and P is connected with the negative. So input junction is forward bias and output junction, that is base collector junction, is reverse bias. So therefore we see that this transistor is biased in an active region, and this transistor is operating in the common base mode. Why I say a common base? Because you see the base is common between collector and the emitter. I have VBE applied and I have VBC applied here. So base is common with respect to emitter and the collector. So that's how we see that the circuit will work. Now this capacitor C2 is again there to filter out any DC component from the alternating signal, and it presents an AC output at this node. So we have seen that this is a common emitter NPN BJT operating as an amplifier. We see how this transistor is biased. We see that how this transistor is biased in an active region. When we say it is biased with an active region, we see that base emitter junction is forward bias and base collector junction is reverse bias, and these two voltage sources are used to make the DC biasing of this circuit. So if you like this video, share it with others. Thank you.